Okay. Now, you probably don't see this, but at this moment, I can sense that you are incredibly stressed. And not just because of the world around us, but because the next two slides, I'm just going to tell you, are by far the hardest two slides that students struggle with the entire semester. And I don't get it because for me it's super simple. But again, until you learn to ride a bike, it seems complicated. Okay, so let's talk about this. By now, you understand what a monophyletic group is, sometimes called a clade or a monophyletic clade. It's a group of life that is natural in that it includes the common ancestor and every single descendant. And typically, they're defined by synapomorphies. Okay, it might be a genetic synapomorphy, it might be a weird anatomy morphology, homologous trait. Okay, so we got that. And so here we have the same phylogeny. These two are most closely related to each other. These two are most closely related to each other. The same phylogeny in both. And what we're doing is drawing a circle around different groups of life. Okay? And so here we've drawn a circle around this group, circle around this group, circle around this group here, circle around this group. Okay? And then we've kind of moved the branches to get these things in the same circle. Now, you can see that this group here says monophyly. It's monophyletic. Okay, this group's monophyletic because the common ancestor, the two tips, is in it, and all the descendants are in it. Okay, the common ancestor is in it, and all of the descendants. Okay, if you wanted to, can I do this? Nope. You could even draw a circle around the entire phylogeny. That would be monophyletic. The ancestor and all of its descendants. If there's three ancestors, that's that rule we covered in a previous module. There's three ancestors, there should be three clades. And the clade should always be nestled hierarchically, smaller within bigger within bigger. Okay. This group here, ignore that it says paraphily or polyphily. It's not monophyletic. What we mean by that is it doesn't follow this rule. Something's excluded. Have we left out the ancestor? Have we left out one or more descendants? So let's go through. Here's the tips. Find the common ancestor of these three tips. Is the common ancestor in this group? It is. So we have the ancestor. Are all of the descendants of this common ancestor in this group? No, we've left out one or more descendants. So this group here, as drawn this way, is not monophyletic. Okay? This group here, let's do that. Is it monophyletic? Well, is the common ancestor of these three tips in this group? Common ancestors back here. Is this common ancestor in the group? No. So we've left out the common ancestor, which means that this is not monophyletic. Okay, so this is monophyletic, these are not monophyletic. If it turns out a group of life, whether it's a name like an order name, mammals, whatever, a group that people have been using turns out to be not monophyletic, then we should no longer use that word anymore. It's not an allowed group of life. Okay, so it's not monophyletic, and we should no longer use that name. If it turns out we do a phylogeny and a group of life that we used to give a name turns out not to be monophyletic, we publish a paper that says, based on this phylogeny, these groups of life are no longer monophyletic. We should no longer use that word anymore. Okay, and then we stop using the word. Now, what are these groups? These groups are called paraphyletic and polyphyletic. And here's the way to think about it. I'm going to draw this here. And since I'm at this, I'm going to draw this other clade, just so you have it here. Let me get rid of the color. Okay, so we have three monophyletic clades. They're all legit. Now let's name this, okay? If we want to figure out whether a group is monophyletic or these other things called paraphyletic or polyphyletic, here's the simple way to do it. Okay, let's go through monophyletic. Is the common ancestor in the group if it's monophyletic? The answer is, think about it. Is the common ancestor in the group if it's monophyletic? The answer is going to be yes or no. Is it yes? Is it no? It's yes. Okay. Are all the descendants of that common ancestor in the group? Well, this one's monophyletic, so yes, all of the descendants are in it. All of the descendants are in it. So if you ask those two questions, is the common ancestor in the group? are all the descendants. I always spelled descendant wrong. Sorry about that. Um, if the answer is yes to both, you've proven 100% that the group is monophyletic. That's its definition. What is a clade? A natural group of life that includes all of the descendants of a common ancestor. Now let's do paraphyletic, and I'm going to center that. This group is paraphyletic. Is the common ancestor of these three tips in that group? Well, the answer is yes. Okay, so just like monophyletic, are all of the descendants of this common ancestor in this group? Well, that's a descendant, that's a descendant, that's a descendant. They're in the group, but this is also a descendant, and it's not in this group. So the answer here is no. And I'm not going to make that just black. We're going to make that scream red. If the answer to this question is no, that group is paraphyletic. Okay, now let's do the same with polyphyletic. Is the common ancestor of these three tips in this group? We already said no. And here we're going to scream this from the rooftops. Absolutely no. That is a huge problem. We'll see why in a second. Are all the descendants of this common ancestor in the group? The answer is also no, but here it doesn't matter. Typically the answer is going to be no, but I'm just going to say at this point, once we know this answer is no, it's 100% polyphyletic. Okay, this is a chart you want to memorize. Remember it. If the ancestor's in it, then it's either monophyletic or paraphyletic, but definitely not polyphyletic. If all descendants are in the group, it's monophyletic. We're leaving off one or more of the descendants. Memorize this, memorize this, memorize this, memorize this. Sleep with it, put it under your pillow, wake up with it. Don't forget this. I guarantee this, I'm not lying. If we had a normal semester where we had in-class exams where it was kind of timed and you have to study and it's high stakes and stressful, I guarantee half the class will get when I give these questions wrong. I'm not lying. And you're guaranteed you're not getting an A on that first exam. Okay. Now on the take-home exam, I'm still going to ask you these questions, and probably even though it's open note, a third of you are going to get it wrong. I'm not lying. I don't know why students struggle with this. It's easy when you figure it out. You got to figure out how to read phylogenies. If you don't know how to read phylogeny, you can't answer these questions. Even if you know how to read a phylogeny, you still might get this wrong. So I understand it's complicated. It's not that complicated. You can do this. Okay. I will ask it again on the second exam. And in a normal semester, we have in-class exams have half the class getting it right. They'll have figured it out by then. 25% will get it wrong. 10% will get it wrong on the final exam. And I'll just say, I'm so frustrated. I don't know how to teach this better. You just got to practice it, practice it, practice it. If you know it, it's super easy. If you don't know it, you're just never going to get it. And when you graduate, I'll be like, okay, they might be a great doctor. They will never understand phylogenetics. And I will just be like, yeah. And you're going to see when we do next week's module that you need to know this stuff if you're going to be a good doctor, if you're going to be a good pharmacist. I'm not lying. It's critically important. Okay? So let's talk about these concepts. It turns out that in the history of life, groups that people used, especially before the 20th century when we were starting to think this way, came up with a group of life that turns out to not be monophyletic. And today we try to avoid those words. So I'm going to give you an example. Paraphyletic. Paraphyletic is defined by excluding one or more descendants. So it is a close to natural group of life because it does include the common ancestor, includes a lot of close relatives, but we're leaving off some things that should be included. It's kind of like when you have your family reunion, you've got that uncle. I'm just talking from experience, and everyone wants to get together, but like no one wants to tell that uncle that the family reunion is going to happen because, like, yeah, he deserves to be there, but no one really wants him. Okay, if it's a family reunion that's defined by biology, you kind of have to include him, whether you want him or not. Okay, whether he makes the world's worst potato salad with raisins, whatever, got to be there. Okay, paraphyletic is kind of like you're closely related, but you're leaving off some relatives that really need to be there. Typically in practice, paraphyletic groups are defined not by what they are, but by what their ancestors had that some of them changed. So for example, there's a group of life called the invertebrates. I teach a course called invertebrate zoology. Um, Shame on me. I should not use that word. The invertebrates are not monophyletic. What is an invertebrate? Any animal that doesn't have bones. Okay, so what do they share? They don't have bones. Yeah, but what are defining them? What do they have? They don't have bones. That's not a fair way to break up biology. Biology is defined by synapomorphies, traits you have. They can be modified, but it's traits you have. The invertebrates don't have anything. They're every animal except for the bony animals. So what are the invertebrates? Every animal except the one group that we care about that evolved bones. Well, we're leaving out the bony animals. Technically, we shouldn't use the word invertebrate. We should say animals, in which case vertebrates are now included. That's a weird example. The one you're probably familiar with is when I say the word dinosaur, you think of the extinct big scary things or big things that eat plants that lived during the Mesozoic and are cool and everyone knew about them when they were in elementary school and you forget them now. Okay, but according to the phylogeny, birds are descendants of dinosaurs, in which case the dinosaurs are leaving out living descendants of the dinosaurs. So if we want to use the word dinosaur as a monophyletic group, then birds are dinosaurs. And in fact, today in biology, we call birds dinosaurs. And that seems weird to you, but because of phylogenetics and we want to use monophyletic names, we don't say the birds exist. The birds are their own clade, but they belong to a bigger clade called the dinosaur. So at Thanksgiving, my wife and I were just talking about this. We eat dinosaur at you call it turkey, but for me it's a big, feathery, mean, weird looking dinosaur. Okay, and it tastes great. Okay, so the word dinosaur, if you want it to be monophyletic, includes birds. If you want to use the old-fashioned ones, then use this phrase, the non-avian, the non-bird dinosaurs, in which case you're defining the groups that are excluding some of their feathered descendants. Okay, so paraphyletic means kind of offset branch, like a paragraph offsets the text. And I'm going to close my, somebody is, sorry about that, making a big mess here. Hopefully you don't. Okay, so that's what paraphyletic is. We're leaving off something. We're offsetting something that should be there. Paraphyletic is kind of like using the word ain't. It's a slang word. It's not formal, it's not proper, but when I say invertebrate, when I say dinosaur, paraphyletic still kind of means something and it's simpler. And so in the slang sense, it's not proper, but it's convenient. And so we will occasionally use paraphyletic groups in this class, um, and I will tell you when they are. Okay, simply because the whole idea of dinosaurs and vertebrates, it's a little complicated. We'll simplify it, we'll slang it up a little bit and use words that aren't properly formal, but we'll talk about that so you know we're kind of being a little oversimplified. Polyphyletic is like a curse word, a racist phrase or assumption. It's putting things together that have no meaning. It's offensive, it's wrong, it makes no biological sense in any real way, and you should just never do it because you're lumping things together that have no connection with reality. We're leaving off things that aren't even related, and putting them together. They have no biological basis being in the same group because they're totally unrelated. Okay, that's what polyphyletic means. It means multiple branches. There's different branches all lumped together. They have no biological basis in reality. This is typically things that are defined by convergent traits that they're flying animals, they're aquatic animals, they're land animals, or they're land organisms. They have no biological really connection other than some ancient ancestral relationship, but the thing that we're using to define the group was evolved independently of one another. And so if it turns out a polyphyletic group exists, I will tell you in this semester we're never going to use polyphyletic terms because there's just no biological basis. We'll occasionally slip into paraphyletic, but it's cheating. Okay, let's see if you're following along. And again, go back to this slide if you need to practice. But here's a question I've circled in a group. It's called the reptiles according to this phylogeny. What kind of group are the reptiles? I'm almost out of time. Pause your computer. Don't check. The answer here is the reptiles as used here are paraphyletic. The ancestors there were leaving out the birds.